1R50, that means 1.5 ohms. If it is 1K5, that means 1.5K. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, I received a message from a comment from one of my friend, my viewer. He asked me to know the value of the resistance. He sent me these pictures. I am making this video not only for him, maybe someone can take benefit from this. When we see the circuit, we see these type of components, and we also see potentiometers, variables like this. Tutorial for potentiometers, how to test, how to check them. There is a detailed video, so today we will not discuss this. It is variable resistance. Basically, what is the resistance? The resistance is a component, a special material which opposes the flow of electrons, which opposes the flow of electricity, which tends to stop the electronic flow, the flow of current. Anything which tries to stop or resist the flow of current, that is called resistance. So today we will see different types. All types are designed to take a special function. Today, first of all, resistance have its own resistive value. It is measured in ohms. Moreover, when it opposes to flow of current, then there is a power dissipation in the material. When it dissipates power, that means it have resistance value and power rating. Then another thing, when the resistance is designed, its material cannot provide us 100% perfect results. So it have a tolerance, plus minus value. We will see in detail. And then every material, when current flows from the material, its internal resistance changes because the temperature effect on electronic motions in their orbits always change their movement. We know at 0 Kelvin or minus 271 degree centigrade, the electronics movement is zeroed. The electrons are frozen. So that means the temperature is effective on the radiation of power, movements, on electronic flow. So to check the value of the resistance, to see it, we see like this ceramic resistor. It is directly, the value is written on the component. 7 watt 6.8 ohm. 7 watt 6.8 ohms. And how we can check, is it okay or no? To test the resistor, ohm value is used. So I will connect one lead here this side, second lead is here, so it is 7.1 ohm. Resistance of the leads 0.3 ohm, so that means 7.1 minus 0.3, that is 6.8 ohms. It is basically a material, wire wound material. Resistive wire is used here. It is covered in ceramic to dissipate the power. We can see here it is 1.2 ohm. When the length of the wire, resistive wire is increased, the resistance keeps increasing. Here until here it is 3.9, and end to end it is 6.9, 6.8k, sorry 6.8 ohms. So in this type of resistors we can read the value directly, and we can check with multimeter to verify is it okay or no. we have this resistor, it is written 2.7 kilo ohm, 5%. So 5%, it is plus minus 5%. That means 2.7 means 2700 ohms plus minus 5%. If the multimeter shows the reading above or less 5%, so that means this resistor should be acceptable and it can be used. So it is 2.705. It is 2705 ohms plus minus 5%, so it is within the range, so tolerance is acceptable. It is 3 watt. Then I have this resistor, it is 4R99, 4.99 ohms. So this resistor is unserviceable, it is bad. It is 4R99. It should be 4.9 ohm, but its internal resistance is increased. So this is not usable, so I removed it from a system. It should be 4.99 ohm, 10 watt. Then I have this resistor, it is 1 ohm, 30 watt. 30 watt, it is used in heatsink. It should be installed on some heatsink. It is 1R50, 1.5 ohm. 1.8 minus the test leads resistance 0.3 ohm. So 1.8 minus 0.3, that is 1R5, 1.5. 1R50, that means 1.5 ohms. If it is 1K5, that means 1.5K. So it is fixed resistor. Then we have another type, it is also fixed resistor. Its value is also mentioned here, 10000F. So you have to consider the last, that is percentage. So it is 1000 and 0%. Very nice. So its resistance, it is a perfect fixed resistor. We can see it is 1.000. So its resistance is 999, and sometime it is changing 1K, so that means it is fixed resistor. So we can check this one. Then another type, it is also mentioned here, 1210, 121, then there is 0. So this 0, so that means you don't have to use any 0, there is no multiplier. If it is 1211, that will mean 121 and 10. 121, 1210 ohm at that time, but now it is 121 ohms. For example, if it is 1212, that means 121 and the 2 will considered, you have to add 2 zeros. If it is 13 at this point, so you will add 3 zeros. Now there is 0, so that means no 0. You have nothing to add here. It is 121.3. 3.3 is from the test leads error. So this error, when we will minus, it will 121 ohms. These are fixed resistors. There is no tolerance. The same is here, 5700, it is 5.7K. So 5.701, 5701 ohm. So it is in reading 1 ohm plus, so it's okay. The same, if any resistor have just only one band, that is black colored, so that means it is 0 ohm jumper. If it is black colored, that means it have no resistance, just as it is used as a jumper. This is also variable resistor. I have discussed it already, so now I will just only demonstrate how you can test it. It is a resistive wire used in this ceramic plate, ceramic cylinder. How much the resistance, how much the sliders are moved, so it will measure the resistance between this pole and this pole. It is 2.21k. At this point it is 6.9k. Here is 8.96k, that means 9k, 9 kilo ohm potentiometer. So we can use the amount of the resistor how much we need. As we studied, the resistive value are mentioned on the component itself, and then we have these colors. For decoding these colors we use this color code chart. There are colored charts also available. So we find, as I discussed, one band resistor that is only black colored, that will be 0 ohm. Other than that, you have 3 band resistor. What is the band? 3 colors. If some resistor have just only 3 colors, how we will calculate it? Skip this band. For that you will use first band, second band, third band. Our first band is first digit, second band will second digit, third band will multiplier. For example, if we see here brown, black and orange, brown, black, orange, brown, black, orange. If we have just only 3 colors, so we have to put in the left side brown, black, red. So brown, locate in the first column. Brown means 1. Write down the number 1. Then the second color is black. This black is here, so write the number black, 0. Then multiplier, the third band is here in 3 band resistor or 4 band resistor, so it is orange, 1k multiplied by 1k or 1000, so it is 10 kilo ohm resistor. It is 10 kilo ohm. Now it is reading 10.11 1000, 10.11. That means it is reading more. If we look at here it is silver, gold. So this golden color, we have to go to tolerance band. This tolerance band, it is plus minus 5%. So we can say gold plus minus 5%, plus minus 5%. So if we calculate 10 plus 10 kilo ohm, 10,000 plus minus 5%, if the reading is between upper limit or lower limit, the center value is 10k. You can minus 5%, you can plus 5%. So if the resistor value falls between this limit and this limit, that means it should, and multimeter reads the resistance between this point to this point, any value, the nominal value 10k, so this resistor will be acceptable. Now there are some special resistors which have temperature coefficient. In some devices there are temperature coefficient resistors. It is 4 band resistor with temperature coefficient. Here are 5 bands, 1, 2, 3, 4, 5. These 3 are for resistance. Next the gold color, that is for tolerance, and the last color is yellow. There should be a question that here are 5 bands and why I am saying it is 4 band. The answer is the fifth band, 1, 2, 3, 4, fifth, the fifth band. Now if I will remove this scale, first band, second band, third band, fourth band, fifth band. Fifth band is here yellow. We don't have the yellow color in tolerance. It is silver, gold, brown, red, green, blue and violet. So yellow color is available in temperature coefficient. In temperature coefficient 25 parts per million over degree centigrade. At each change in 1 degree centigrade, in every centigrade, its resistor can change 25 parts per million. So the last band, now we identified the last band, it is temperature coefficient. So before temperature coefficient there is a tolerance. So here is tolerance band. So after that there is multiplier band. If we start from right side, multiplier. So there is no third band here. The third band is here is multiplier. So let's calculate it. It is brown, green, multiplier is orange and gold, yellow. Brown is 1, green is 5, then multiplier is orange. So orange is 1K multiplied by 1 kilo ohm, then gold is plus minus 5%, then yellow is 25 ppm per degree centigrade. So it is 15K multiplied by 1K, so 15 kilo ohm plus minus 5% plus minus 25, it is coefficient. So at each degree its resistance can affected about 25 ppm per degree centigrade. Let's check the value. We calculated 15K. So it is 15.05 K. So 0.5, that is tolerance. So 15K is nominal value. As I discussed, if we calculate it plus minus 5%, 15 plus minus 15, so our range will start from this point to this point. If the multimeter will read 15K plus this value or minus this value between these brackets, so this resistor is good. So here I have resistor brown, black, brown, and the last band is silver. Calculated brown, pick the first brown, that is 1, black 0, 1, 0, and brown. Multiply it by 10. This is multiplier band. 1, 0, that means 1, 0, that means 10. 10 multiplied by 10, it is 100 ohm. It is 98.7, and for silver plus minus 10%. 100 ohm plus minus 10%, that means this resistor is here 100 ohm plus 10%, that means 110 ohms, minus 10, 90 ohms. If our multimeter reads the resistance 100 ohm, that's nice. But if it reads 90 ohm, that is acceptable. If it reads 110 ohm, that is acceptable because it is the tolerance. So if it reads 85 ohm, that's not good. If it reads 120 ohms, that means it is not good. So if it reads between this limit, that's nice. It is green, brown, silver. Green, brown, silver, and then gold. Green 5, brown is 1, 5, 1, silver is multiplied by 0.01. So 51 multiplied by 0.01, that is 0.51 ohm. So it is 0.8 ohm. 0.5 minus this test lead error, 0.3 ohm. So 0.5, 0.8 minus 0.3, so 0.5 ohm, which is calculated, we calculated it here by the color. 5, 1 multiplied by 0.01, that means it is 0.8. 0.8 including this test lead error. If you see, it have 1, 2, 3, 4, 5 colors. So it is 5 band. Now we should have a question that it have 5 bands and it have 5 bands. So why we cannot say the yellow is for temperature and other bands like this? If we see this band yellow, then there is gold. So it is tolerance band, it is temperature coefficient. But in this 5 band resistor, you have to see the distance between the bands. Here all bands are at same distance. Here all bands are at same distance. But in this resistor, if we measure the gap between the bands, so the rightmost band have more distance than the other bands. So the more distance band should be kept at right side. In the camera maybe it is hard to identify, but if we see very carefully, this band has more distance. Or if this band is more wide, more thick, it have more width, the band is wide, so it should be identified that it is tolerance band. It should be at right side. The same distance will be kept at left side. If we see here, this distance is more. So we have to check like this. So it is yellow, blue, black, orange, then there is brown. Let's calculate this resistance. Now we have 5 bands. There is no temperature band. The first yellow is 4. The second band violet is 7. Then there is black 0. Write the digits like this. Then the band is multiplier. This is first digit, second digit, third digit, multiplier. So value in multiplier will be multiplied. So we have orange. Orange is 1K multiplied by 1K. Then there is brown, so plus minus 1%. Let's calculate 470 kilo ohm plus minus 1%. It is 479.8 kilo ohms, 480K. So our value should 470, but it is plus minus 1%. 470K plus minus 1%, If the value becomes between these, that means this resistor is good. Otherwise, we have to change it. If we see this resistor, 1, 2, that are orange, silver, and one band is far away from these two bands. So the away band, the right side band, should be at right side while reading the resistor. So orange, silver, and tolerance. Orange, silver, orange 3, 3, and then multiplier. We will not use this band because it is 4 band resistor, so we don't use this value in 4 band resistor. So for 4 band you have to 1, 2, and multiplier. So multiplier is silver 0.01. It is 3 multiplied by 0.01, so it is 0.33 ohm resistor. Then we will consider, if we have the next band, then we will consider the 6th band. So 5 band resistor, we can calculate this. I don't have the 6th band resistor here now. So if we have 6th band, then we can identify like this. Then there are resistor packs. It is a molded pack of resistors. So it have 1, 2, 3, 4, 5, 6, 7, 8. It is 8 pin, but it have 7 resistors inside. One pin is common, and other pins have the same resistance, which will be indicated here. It is 2.7K. So pin number 1, single in line, plus minus 2%. So the left pin will common, and every pin should have 2.7K resistor. 2.7, 2.7, 2.7, 2.69, 2.69K. So it is the molded pack. Then we see in the IC shape. It is not a IC, it is a resistor pack, and there is a value of the resistance mentioned on the component. It is 3.3K. So every pack, it have its pin identification. If you will go to part number mentioned on the component, then you can find the data sheet, and here pin number 16 is common pin. So index pin is pin number 1 is here in the dot, and this is left identification. So pin number 16 is here, pin number 1 is here. So you have to check the resistor at each pin. Pin number 16 is here, pin number 1, 2, 3, every pin it have the same resistor. Any resistor is missing, you can change it. So pin number 16, like here, pin number 16 to 15, 3.3K, 16 to 1, 3.3K, 16 to 2, each pin will give same resistors with pin number 16. The same resistors are here, 2.2K and 1.1K. And we have another pack that is called 1-to-1 resistor. So it is 220 ohm. So it will give a resistance between two pins, 290 ohm, and every resistance, it is independent. It have no connection with the other all pins. Every resistance is independent with each other. Pin 1 with 16, 2 with 15, 3 with 14, like this, and no resistor is connected to other pins. Just only one resistor is between this, like this here. And we also see the resistors like this on IC sockets. It is pin number 1 and 16. Here it is in different sizes and different values. If we see, these are same resistors, same value, but it have different value. Brown, black, brown, 100 ohm, 100 ohm, 100 ohm, 448K, 470 ohm, like that. So friends, I hope so this video is informative for you. If it is informative, please hit the like button, and if you want to watch my future videos, you can press bell icon button if you want. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.